Okay, let's get started. So yesterday we spent some time building a testing framework in the vein of Mocha. And today what I want to do is fill in a couple holes, some things we didn't get to yesterday, and kind of clean it up a little bit. And then there may be some time left over at the end to just talk about any questions people have, or just do like general office hours kind of stuff. But let's take a look at where we ended yesterday, which is here. So we had this, we had these tests, right? Look a lot like Mocha tests, using the same describe it syntax. And we're using the same like call the done, a callback when your tests are done convention that Mocha has. And then in this it.js file, we're sort of exporting this describe function, which creates a test group object and pushes it onto an array of test groups that we're just storing here in a const in this package. We've got the it function that creates a new test object and sort of pushes it onto the array of tests for the current test group. And the interesting things I think were happening here in test.run, which creates a promise that sort of wraps the function that's in the it block. So this thing here, for instance, this function we're going to grab, and Dad's sending me text messages. And this is where we run it, right? Right in here. And so what we've been doing is, passing in this done callback that the test can call when it's done, that will force us to set the state to passed and resolve the promise. And we're trying to catch errors, which represent failed tests. And changing the state to failed, set the error message, and then again, resolve the promise. And this worked for most cases, or for the simple case that we're looking at. And if we, let's see, node tests. And if we just execute this file, we'll see that it works. We see the failing test fails, shows up in red. We see the error message. See that one test failed. So that's working, but there are a couple issues with this. One of them is this awkward run down here at the bottom, right? We're importing describe and it, and we use them to sort of set up this test suite, but then to actually kick it off and actually run all of the tests, we have to explicitly say run here at the bottom, which is not something you have to do with Mocha, because with Mocha, you're sort of running the Mocha executable and passing it the test files, and it sort of sets everything up and then kicks off the run after all of the tests have been defined. So we want to do something similar to that here. So let's start with that part. We will call our executable tester. So I'm going to create a tester file, and this is going to be a shell script. So we're going to make it an executable file, and in Bash, when we execute a file, I should really turn off notifications. Let me see if there's a way to do that. Sorry, I usually do this before we get going, and I just forgot today. Now I'm paying for it. There we go, notifications off, great, okay. So, my parents are at the location where they filmed What About Bob, and they're very excited about it, which is I think why I'm getting a bunch of texts. All right, so we're creating an executable. When Bash executes a file, it'll look at the first line of the file. Some of you may have seen this for a line that starts with a hashtag and an exclamation point. Exclamation point is sometimes called a bang. So you'll hear this referred to as a shebang line, hash bang, shebang. And it'll look there for a path to a program to use to interpret this file. So if we want to write an executable in JavaScript, we can grab the path to node, which for me right now is this big old ugly thing, and put that in a shebang line. And then we can just write JavaScript in this file. And so what I'm going to do is I'm going to, let's grab this run method from it.js, and then we can use process.argv to get the name of the test file that we want, right? So this will be the file name equals fine name. It's probably a fine, but we'll call it a file name. And then what we want to do is we want to require that file name, right? The test file. But this needs to be at least a relative path, or maybe even an absolute path to that file. And what we're going to get on the command line is probably just like the name of the file. Because our command line is going to plug in something like this, like tester tests.js, right, to run the test file. So we're going to get something like tests.js, and we want to translate that into, at the very least, something like // that's like a valid relative path, or even like the absolute path to the file. And so what we can do to convert this is use something called path, which is a built-in node module. Right here. And path, we can say path.resolve file name. And that'll give us an absolute file name, absolute file path. And so we can require that. So that'll require in the test file, and then all we have to do now is call run. And so that sort of gives us that setup, and that should mean that we can remove run from the bottom of this file. And then in the command line, if we change mod tester, so we're going to give tester executable permissions. So if I list it with a -L, I should see that X is here, showing that I can run it as an executable. And that means I can just say tester tests.js, and it'll run my tests for me. So now that looks a lot more like what we would expect. And I could even put this in my package.json. I can change my test command to be tester test.js, and should be able to say npm test now. There we go. So now I can npm tests to run my tests. Fantastic. So that fixes our first problem, right? That now we don't have to say run at the bottom of the file, and this looks a lot more like a kind of a grown-up test framework with a little executable that ships with it. Any questions about that? Check my chat, Zoom chat here. Make sure people aren't typing things at me. No. Okay. Awesome. Moving along. Just shout at me if I'm going too fast, or if you want to slow down or explain something else. I'm happy to go down rabbit trails, as always. Okay, so we've got a tester script. That's great. Our tests are a little cleaner now. That's nice. The bigger problem we had with these, if you will remember from yesterday, or from the previous video, if you're watching this on YouTube, is that this expectation here that fails, if this happens asynchronously, things start to go wrong. So if I'm testing some asynchronous function, like this, for instance. So say that this is actually going to happen in a callback. In this case, it's just a callback to set timeout, but it could be a callback to some like fetch database query or anything else that's asynchronous. So this should work, right? In Mocha, this would work. This is how you do testing asynchronous things. Just put the expectation in the callback and then call done when everything's finished. In our case, though, if I test.js, this thing, we see I get the passing tests. The failing test never gets printed out at all. And then I get this error just printed out to the screen here at the bottom, this giant error. So what's happening here? So what's happening is, let me bring up this code together and see if we can walk through it. So what's happening is, I call it, I pass in this function, right? That function gets stored in the test object, and eventually run gets called for that test object. And inside this promise, we call this dot function. So when we call this line here, 45, we are invoking this function that's being defined here on line 15. And this runs and returns immediately, right? And the contents of this function cause it to basically register a callback function that's going to be fired off in 100 milliseconds, right? So we sort of set it and forget it. We register this function and say, yeah, in 100 seconds, call this function. And then this function that starts on line 15, the test itself, returns immediately. No error was thrown, so we don't go into our catch block. And the promise never gets resolved. And notice the promise is going to get resolved when done is called, or when if there's an error thrown, then it'll get resolved in the catch. But neither of those things happen right away, and this just sort of ends. And this promise exists, but nothing's watching it, nothing's waiting for it to get resolved. So 100 milliseconds later, when all of this stuff happens, this error gets thrown here. So done is never called because this throws an error, right? And then there's nothing listening for that error because this is just a function that's kind of sitting out there in no man's land, you know, being executed asynchronously. So what happens in that case, it turns out, is Node does give us a way to listen for exceptions that are thrown and aren't caught by anything. Exceptions that just sort of bubble up, possibly because they were called in some asynchronous callback that's just being executed, like because some other thing triggered. In this case, like the timeout triggered. And the thing that Node gives us to listen for those things is, it's in process, just like we have process.argv. We can also add, I'm going to put it here, process dot, let's pull up a browser so we can get the, show you where the documentation for this is. Here we go. So what's going to happen is UGHT uncaught exception node. So the node process is an event emitter. So there's all these different events that get fired, and uncaught exception is one of them. And so what we can do with the process object is we can say process on uncaught exception, and we can register our own little bit of code that will get called with an error in the case where an exception gets thrown and nobody's listening for it. It's not inside a try catch because possibly it's in some asynchronous callback like we're experiencing. So let's see what that would look like. So if I add this process on uncaught exception handler, let's just do this for now and say uncaught exception, error dot message. So if we just log it out, there we go. So we see this big exception doesn't blow up all over the screen. It gets caught, and we just print it out. Uncaught exception, expected 4 to equal cheese. So we're close here, right? We've found where this exception is getting thrown and how to grab onto it. What we need to do is associate it back to the test that's in the middle of running. What we need to do is keep track of what test is running at every given point in time, so that if any uncaught exceptions happen during that time that that test is running, before done gets called, we'll know, oh, we can just, we can catch that exception and we can treat it as though that particular test failed. So what we're gonna do is we're gonna create sort of a package level variable here. It's going to be a let, because we're going to reassign it, and we're going to call it the current test, right? And that's going to start out as null. And then, when a test starts running, right? Whenever we go to run a test, what we can do is we can say the current test is equal to this test. So we sort of register it and say, okay, the test we're running right now is this one. And then whenever the test completes, right, when done is called, or when an error is caught this other normal way, we can set current test back to null. So now, after this function gets called, but before done gets called, before we get to this done, before we call done here, current test will have in it a reference to this test object that represents this test we're running. So that here, we could log that out, right? We could say uncaught exception during current test name, and then let's do one of these. Let's see what that looks like. There we go, uncaught exception during flies, expected 4 to equal cheese. So now we can see that we can grab the test. We know that this is the test that failed, right? We've got a reference to it. So now we know that that test failed. Current test has failed. So we just need a way now, given a test object here, we need a way to tell that test, hey, fail yourself, mark yourself as failed. Currently that just happens here, right? That's just this code right here, right? We set the state to fail, we set the failure message, and we resolve the promise, right? And set current test to null. So we want to do all of that stuff for this test. So let's do this. Let's create a new method, test.prototype.failTest. Function, and we want to do this stuff basically. So most of this is pretty straightforward, right? Changing attributes that are, that we access through this.state, this.failure message, set the current test to null. This thing here though, resolve, we need access to that resolve method, which is getting passed in here to this promise, to this executor function. So to get a handle on that, what we can do is, as soon as this promise starts, we could say this dot resolve promise resolve. We can just store a reference to that resolve function so that we can call it later. And we can call it here, this dot resolve promise. And we could even get a little bit more clever here. We're passing in this as an argument, but now we're calling this as a sort of an object method. So we could even say resolve promise is a function that takes no arguments and then calls resolve with this. And that lets us just infer that argument. And since we have this method, we might as well use it here and here to be consistent, right? So let's see what that gets us. Fail test out one more piece. So we have this fail test method in here. And that's what we want to call now here. So we can say current test. If there is a current test, so if there's a test running right now, which there might not be, then we're going to call fail test to sort of mark that test as failed and resolve it. And let's see how that looks. Aha, failure message equals error.message. Error is not defined. So we're referencing error here in our fail test, but it's not defined anywhere. We copied this code from up here where we're getting the error from the cache. For our fail test method, we're going to need to pass an error in to tell it what error to fail because of. What we might want to do is just say, just pass in the failure message. And then up here, we can grab the failure message from the error.message. There we go. So now our asynchronously failing test, we sort of catch that asynchronous error and we go back and we mark that test as failed and we get the behavior that we get in the synchronous case. And there's a little bit of an opportunity for us to clean some things up here. You'll notice that we did a lot of copying and pasting code here to get this working, right? These 4 lines from 58 to 61 are basically identical to 67 through 70. And that is on purpose. The nice thing about exactly identical code is it's really easy to remove. We're just going to change this to a call to fail test. Error.message. Right? Yep. So that simplifies that a little bit. We can make sure that our tests still run the way we expect them to, and they do. So that solves the next sort of tricky problem that we were having here, which is this trying to get this behavior to work right, these asynchronous failing tests, and that we've got now. So there's one more thing we want to do, I think, which is an important feature of Mocha that isn't as obvious, but Mocha has a timeout. So you can imagine a case where done just never gets called. Maybe I forget to do this. Or maybe I call a function and I pass in like a callback, right? Expecting the callback to be called. But for some reason that callback never gets called. We could simulate that by making this timeout really long, right? We run this test here, the test will run and it'll just hang, right? And in this case, it's gonna hang many, many, many seconds until that timeout runs out. But there could be some bug in our code that prevents the callback from ever getting called, in which the case the test would just hang forever waiting for done to get called, and it never does. So what Mocha does in these cases is Mocha by default has a 2-second timeout on tests. And if your test takes more than 2 seconds to run, if 2 seconds goes by and done never got called, then it will just fail the test and it will say, you know, test failed because it timed out. And you have the option to either increase the timeout for a particular test if you anticipate that it should take longer than 2 seconds. But usually your tests aren't going to take that long to run. So we want to handle that case. How would we implement a timeout here? So we're just going to write a test here that runs too long, right? So let's do this one, and we can even make it. In fact, what we can do is just write a test that never calls done, right? So this should time out, because done never gets called. Something terribly, terribly wrong went wrong. What did I just do? Scribe master, scribe down. What's going on? I guess let's move it back to this. Right, okay, so there's that timeout thing happening. Yep, okay, so what we're gonna do is add a timeout. So what is that gonna look like? It's gonna be down in this run function again. And we want to kind of time how long we're waiting for done to get called and bail if something bad happens. So what we can do here is just do another set timeout. We can say const test timer equals set timeout. And I'm going to do something after 2 seconds, right? So what are we going to do after 2 seconds? So after 2 seconds, we can throw a new error, test timed out. Right, and that error will go up, and it'll get caught by that uncaught exception handler, and then fail test will get called, and it'll look just like a failed test. The simpler, more direct way to do this, now that we have this handy method, is just to call fail test. We can say if the timeout gets reached, then fail the test with the message test timed out after 2 seconds. So, and then the only thing we have left to do is, in the case that the test does finish, we need to short circuit this timeout, right? This set timeout timer is clicking away, waiting for 2 seconds. We want to cancel it. And we can use clear timeout for that. So set timeout, it turns out, returns this sort of timer object. And then you can, at some later date, call clear timeout test timer to cancel that set timeout call, basically, to sort of unregister this callback so that it won't get called after 2 seconds. And let's make that the first thing we do, just to make sure that it happens. So let's see how that works. Set timeout is not defined. The thing about code is if you misspell stuff, it gets very mad at you. E comes after M in timeout. Here we go. All right, so both of these tests are timing out now, which is kind of what we want, but not quite. Why is the first one timing out? Bum, 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 set timeout, done. Let's see what happens if we comment this one out. All right, so that one times out after 2 seconds, but this one should not. Right, that one just fails. And oh, okay. So I think what's happening here is these timeouts are getting no, somehow that should still work. Something unexpected is happening. So we're setting the timer, clear timeout, this state, fail test. I wonder if it matters if I change this to be a passive test. Nope. All right, well, somehow the way these callbacks are getting registered, somehow I think it's waiting. This one's never getting called. So let's see. Let's log this done with test.name. And current test. Let's see if that helps clear up what's going on here. Started eats, started dog, started flies, started times out after 2 seconds. Eats, flies, times out after 2 seconds. None of these are, test is not defined. Oh, well, that's not helpful. This dot name. There we go. Started eats, done these, started eats, done these, started flies. So it starts this second test before this one finishes. That's what's going on there. Well, let's go figure out why that is. So somehow, this is where this kind of code gets tricky. Somehow this test is starting, and then before it finishes, this next test starts. And that seems bad. I wonder, does the same thing happen if we switch the order? Or is it something about this failing flies test that's hurting us? No, it happens even if we switch the order. Let's put that back and okay, so when the test fails, my guess is we're probably getting down here. Or actually, no, we're probably getting up here. Where's our uncaught test? There it is. So we're finding an uncaught exception for current test.name. Started times out after 2 seconds. Started flies. So we're not getting an uncut exception for flies. That's interesting. It doesn't get to that part yet. Somehow flies starts and then done gets called right away. I'm not sure why that is. Let's look where we're running these tests and see if there's some reason they're not happening in order. So we're running these down here. We are, that's right. So group tests map. So we're taking all these tests and we're calling run on all of them. And then we're getting the promise and we're sort of like going through them in order. But we're sort of starting all the tests here at once, which is not really what we want to do. We want to start one, and then once it's completely resolved, then we want to call test run on the next. So I think what we may want to do is we may want to do this and say group tests here. And then here, do this and say test.run. Then do test.run. Yeah. Let's see if that fixes it. Ooh. Promise created in a promise each handler, but not returned from it. Oh, I got to return the promise. Silly me. Return. There we go. Okay, so that fixes it. So map series will go through each of our tests and then run this block of code for one at a time, waiting for all the promises to get resolved. And that is really what we want here. We can maybe shorten this up a little bit by doing so for each group test, we're going to do this thing. Yep. There we go. Perfect. All right. So a little bit of map series magic there to get that just right. But now we've got a testing framework that will handle those timeouts for us, which you really need if you're going to start doing anything asynchronously, because you're never guaranteed that those callbacks will get called. Especially if you're writing tests, and the assumption when you're writing a test is that the test will sometimes operate on code that is broken. That's the only reason that the tests are useful, is if they can actually show you when code's not working. And if one version of not working is the callback doesn't get called, you want a test to fail for that, not to just hang indefinitely. So there we go. That shores up some of the little pieces that were bugging me about what we did yesterday that we didn't quite get to. Let's remove these debugging statements. Describe log. Those are logs that I want. And then there's just one more thing we need to do here, and that is we need to do something about this file. This is a 100-line file that has 2 different objects described in it and a bunch of just like top-level methods that are being exported, and it's getting kind of hard to follow. So what I want to do is move these objects out into their own files. So we have this test object here, right? Function test with its run method and its fail test method and its toString method. And all of that can come out into its own file. The other thing it's going to need is this stuff that deals with the current test. So we can put all of this in a separate file, and then just module.exports test. And here, we can just import it from test. Let's see if that still works. Chalk is not defined. And chalk actually needs to go in here with the test because we use it here. So let's put that import at the top of this file. Seems to still work. That's great. So now we got that out. So now our file's only 50 lines long. That's great. It's got the run method. It's got the it method. It's got this test group stuff in here. And that is something that we can pull out as well. So let's remove that test group stuff and create a test group file, stick it in here. Export it, and then just import a test group like this. Nope. Test group, test group. What has gone wrong?
You misspelled the module, Trevor.
Yeah. What's up? Somebody have a question or comment?
No, you misspelled the module. That's what it was.
Misspelled the module. Thank you so much. Test group. Where did I spell it?
Module export is moduel. I think it's Spanish.
Ah, right.
Ha ha ha.
Thank you so much. There it is. Okay. So there's our failing and timing out tests. Perfect. Okay. So now we have these nice little contained modules, right? Test group really isn't doing that much, and now it's kind of obvious that like all it does is wrap the name of the function and give us these count and failure methods. That's fantastic. And we have a test object that represents the test. It's doing a little bit more because it's, you know, keeping track some state of whatever the current test it's running is. And it's got this method, which is still a little scary. This run method is scarier than I would like it to be. And I'd probably want to come back in here and see if we could refactor that and make it a little more readable. But at least all the test stuff is in one file. And then we have our sort of main export that exports describe it and run, and there they are all together here in this nice 35-line file. So that's kind of a simple, just like break it into modules refactoring, but it makes this a little bit more sane. You don't have to crack open the whole thing to look at any one part of it. And that gives us a simple, it's not very full featured, and you definitely want to use something with Mocha. There's a lot more features that Mocha provides that you're going to want. And there may be other edge cases that this doesn't handle, but the main idea here is to give you an idea of like the kinds of things that a test framework is doing for you. This is why you use a test framework. You don't have to write all of this stuff yourself, but at least now you know kind of what's going on behind the scenes, the kind of problems that it's solving for you. Hopefully that demystifies Mocha a little bit for you, which was our goal. All right, great. And that's all I've got for today. We are ending early as I thought we might. So if y'all have any questions or anything like that, we can move to office hours. I'm just going to